Good afternoon, and thank you for joining us on our call today. My name is Christina Spearman from Transcat, and I'll be your moderator this afternoon. Our webinar topic is how to maintain your temperature equipment. This topic is being presented by Travis Porter from Fluke Calibration. Travis has worked at Fluke Calibration in American Fork, Utah in a variety of capacities for the past 22 years, including customer service to technical support. His current role is Inside Sales Account Manager. We expect today's presentation to last roughly 45 minutes, and then we'll answer any questions that have been submitted. During any time of the presentation, you can send questions through the question box to the right in your webinar controls. I also want to mention this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Travis.
All right, welcome everybody to this presentation on maintenance tips for temperature calibration equipment. Just real quick before we get too started, I do have a little bit of allergies, so if you hear me quickly mute, it's probably because I had a quick sneeze come on. So I'll do my best to avoid those, but basically we're going to talk about the equipment that you've invested a lot of money in for your calibration lab and how to do some preventative maintenance. This is key to keep the units running at their very best and helping to reduce costly repairs and downtime. So as we get going now, we're going to start our first part. I should say here's the agenda. We're going to start with our calibration baths. We'll move to Drywells and then to micro baths. So we'll get started on our big baths or standard baths. Why do we want to maintain our units? Well, it's going to extend the life of the unit. It's going to provide us with better measurements. And it's going to prevent downtime or basically any untimely repairs that we were not prepared for. We're going to go over some basic tips of cleaning the bath exterior, the condensing coil, and then we'll kind of jump more into some of the controllers, which is internally to the units, and also check the over temperature cutout and why that's a good idea. This will kind of lead us into some more general topics of selecting the right bath fluid, proper ventilation, what is polymerization of the fluid, and then a cleaning solvent if you do happen to have a problem where your oil does polymerize. So basic maintenance is very clean. You don't want to spray anything directly onto the bath. You want to put it onto the towel or cloth is being used. Ethanol works very good for a lot of the silicone cleanup. It doesn't usually hurt the paint in any way. OS2 is this chemical that you can get from Dow. That one helps dissolve silicone residue and silicone oil that's polymerized. So again, we'll talk a little bit more about that. When you're using, or wiping, again, just wipe away all the silicone from the top of the unit. Another tip is when you're removing the probes from the bath, instead of coming straight forward, straight back, sometimes it's a good idea to go left or right. This way it avoids any potential fluid dripping down onto the controller that is at the front of the bath. So again, just periodically wipe the unit down to remove the excessive silicone oil. And again, too, silicone oil does creep. It gets everywhere. Again, as it's being used at higher temps, it does kind of evaporate, kind of condense. So that's a reason for that. You can also periodically remove the top cover of the bath. So again, on the baths, they do have a seal. It is not a liquid seal, but is more a ventilation seal. That's where the lid sits on top of the tank. And it is good practice every once in a while to kind of wipe the oil out from underneath there to prevent any of that silicone creepage coming down the sides of the bath that may have condensed over time. The next thing we want to talk about, which is probably the most productive thing to do with your baths that do have a condensing coil, is to actually clean these. Some of our baths do have a door or access panel, like this one in this picture that you can see. Some of them you do have to remove the panel. Usually it's just a few screws to remove that. And then you've got your internal condensing coil. So again, you'll need to locate that based on the type of unit that you have and whether you need to remove a panel or if it's got an access door. It's really good to kind of have a set schedule for cleaning the condensing coils and fins. This would probably be more relevant to the type of environment you're in. Most labs tend to be fairly cleanly, but I do have customers that are using baths in more of a production environment where it's not as cleanly, so the dust and debris tends to build up a little more quickly on these condensing coils. So again, depending upon your environment, this may or may not be something you need to do monthly or every few months or quarterly. It's kind of up to what you deem necessary in your kind of a quality or maintenance scheduling. So once you have access to the coils, you're just going to use a low pressure air source and blow off the debris. Some people will use a vacuum in tandem with this. As they blow it, they will vacuum up the dust that comes out as well. If you notice any of the fins have become hit or bent, you can purchase a fin comb and kind of give these a quick brush, and that will straighten the fins back up. But again, with that, I would probably suggest, if you've never seen a fin comb used, to kind of hit up YouTube and kind of look, because again, when you do fin brush those, again, you are dealing with a really small gauge aluminum, and so you got to take some care in doing that versus because again, if you jam it in there, potentially you can damage the condensing coil. All right, there's a couple things you may notice that go wrong with the bath over time. Sometimes your controller will always say initialize, or it's like a short INIT every time you power the unit up. Basically, this is where your internal battery controls the, I guess it's the non-volatile RAM has kind of lost its charge. And so to get to this, you're going to remove the 4 little screws that hold the front panel on. And then the front panel will just kind of lift, and you can kind of hang it forward in this example here. And then it's just basically like a 3-volt coin battery that's on the display board. When you're doing this, you do want to have the unit not connected to any AC power. Again, you don't want to be in there poking around with anything. So again, this is a 3-volt type coin battery. When I was in production, we would always make sure they were 3.4 or higher before we installed them. But to remove them, it's pretty simple. You can just use a little flat blade screwdriver to kind of pry up the pressure fit and then slide it out. So again, typical lifespan on these is 7 to 8 years. I've even seen them go 10. Kind of just depends on how much the bath is being powered on or off. So again, once you get the new coin battery installed, then you will just kind of, again, in reverse, set the display back on and install the 4 screws that were used to remove the panel. The next thing some people will adjust, depending upon the bath and fluid, is the over temperature cutout. This is kind of a built-in safety feature of the baths. All of them have that. Usually at the factory, the hard cutout is set at just a few degrees over the maximum temperature of the bath, because again, you want to be able to go to your max temperature but not bump into the cutout. But again, some people will limit this or use the soft cutout setting here based on the fluid type that they're using, so they do not overtemp the fluid. And again, too, it's always sometimes good practice to go in and maybe set this down to a point where you will bump into it, just to make sure that the temperature cutout or the soft cutout is functioning. So to get to this setting, it's quite simple. Is you're just going to have the bath on and functioning, and you're going to hit the set and exit keys simultaneously. Once you do this, the unit's display will show a % power, which is for the heater controlling the bath, and then you'll hit set again. This will give you your proportional band setting, and then if you hit set again, it'll say cutout, and then there's the set there where you can use the up or down arrow keys to kind of take that set point up or down. So again, this is again something that most people will adjust based on the type of fluid that they're using, so they do not inadvertently overtemp the fluid. Again, a lot of our baths have more capacity, and there is quite a variety of fluids in the industry. And unfortunately, we don't have a single fluid that works from very cold to very hot that we can use to get some of the performance specs that we need. So again, more or less a safety feature. And again, too, just in case too, something goes wrong in the bath, for instance, it runs into a thermal runaway situation. Say we lose a cooling or a cooler, and then it's just continually heating. This should cut out the power to the unit. So when the set point is bumped, the display just triggers the relay, and then it'll go into a flash cutout, and it'll stay in that mode until the temperature of the bath comes down from or below that, and then it will reset that parameter and allow the power to go back through the circuit. So again, just something to check periodically, make sure that it is working. All right, and along with the cutout, again, we talked about different types of fluids. So again, unfortunately, we don't have something that performs as good as alcohol at -100 and as good as the bath salt at 550C. So unfortunately, a lot of times have to use a variety of fluids. And so usually this is temperature dependent on where you're going to be performing the most of your test points. So again, going off this sheet here, it kind of goes from the halocarbons and alcohol and the dinylenes, which are usually typically used for more cold applications. And then you can get into the ethylene glycol or antifreeze and silicone and mineral oils, which are kind of middle of the road. And then if you're running consistently above, say, 220 or so, a salt bath is actually the better solution long term. Even though there's a little more investment up front, you will make that back in spades as far as the replacement of mineral oil, because again, most mineral oil, even the types that are rated for 300C, there is quite a short life at that very, very top temperature range as the polymers bake off, and then they do start that polymerization buildup or polymerization chaining process. One thing that can happen in the cold fluids, and this is most common when using alcohols or ethanol, methanol, or halocarbon, is water can build up in the fluid and basically cause an icing. And when this ice forms, basically the cooling capacity of your bath is going to be degraded. So depending again to where you're holding temperature to, and how long and what the conditions are of the lab or space that you're working in. I've seen alcohols ice in as little as a month where they have to be replaced, or I've seen them go almost a year, about 9-10 months if you're in a fairly dry environment. One thing we did notice in our lab is that the ethanol versus methanol, the ethanol does saturate at a much higher rate than methanol. But again, there is some considerations when using methanol, and some people don't like the additional safety concerns that need to be considered. The other thing too with halocarbon is you can actually turn off the bath and just allow the unit to sit, and the ice and or water in the fluid will actually separate and float on top of that, and it can be ladled off. And once you get the majority of it ladled off, you can then actually slowly heat the fluid up to kind of 90C and kind of approach close to 100 and kind of boil off the remainder of that, the water that's condensed into that type of fluid. All right, so again, with any of the baths, and again, this is more typical again for the hot baths where you're using oils that do off gas or the salts, you do want to have proper ventilation. We do have kind of a fume hood recommendation based on different oil types. So again, if anybody needs that, that's on our website. Basically what we've done in our lab is we do have basically about a 600 CMF fan that vents out, and then we basically created a trunk with kind of these legs that come down to the various baths. to pull the off gases out of the lab, making a much more better environment for our technicians. So good. Sometimes too with the silicone oils, you do want to have, like, at the top, instead of just going straight up, we have kind of a little U in the pipe. And so as the evaporated oil kind of collects and condenses, we can drain that. I don't have a good picture of that here. But again, that's another little tip that we found over the years, is having almost like a U or a P-trap type design where we can drain it out. So again, it's very helpful that way versus getting oil sucked up straight through into the ducting. We did talk a little bit about polymerization. So again, even with our very, very high temp fluids here, which you can see is the 710/500 at the bottom, which we mark it as 5017. Once you start getting upwards of, 220, 250, and then when you go to the max hours, you can see the life of this fluid is fairly short, even though, you may get a broader range. If you're using things, again, exclusively between 220 250 C, again, I would recommend that you move to a salt bath, just because that fluid will outlast the bath. I've had several customers that have used the fluid, which is the original fluid, for 10, 15, 20 years. Again, the bath, which is a nitrate-nitrite mix, again, rarely is going to cook off any of the properties. What happens over time with the bath salt is the low end melt point tends to raise by about 20 degrees as some of the nitrates and nitrites change states. But other than that, it's pretty much one and done, versus replacing some of these higher temp fluids, which can be fairly expensive. So if you do run into a situation where one of your silicone baths does polymerize, this is the stuff you want to get with. It's from Dow Corning. It's called OS2. So basically, it helps soften and remove basically the silicone oil that's kind of chained and become almost like a silicone. So it's odorless, evaporates, really good for cleanup. Another couple of tail signs to watch for with your silicone oils is over time they can, with some of the higher temp applications, discolor. So they'll go from a clear to more of a honey color. That doesn't always mean it's going to polymerize, but it's just showing the oxidation. I've also seen the polymerization process take place with the fluid being completely cleared and looking new. So again, for each application, you're going to kind of have to keep an eye on it. Usually you'll start to see what looks to appear like little bubbles if the polymerization is occurring in the clear fluid. And it just looks like little pockets of these the chained molecules that are basically making pockets of little gelled plastic in there. But again, another sign if you have a larger bath is if the stability of the unit starts to waver and it's been working fine thus far. Sometimes the stability will be an indication that the fluid is starting to lose its life there. All right. So now we're going to move on to our Drywell section. So again, same basic concept. Why would you want to maintain your Drywell? We're going to, again, make sure that the measurements are going to maintain. We're going to prevent some downtime, and more so in Drywells, when we get into just the styles with the metal blocks that are removable, the cleaning of the inserts prevents them from getting seized or stuck. So again, same basic concept. You're going to clean the exterior of the drywell, again, not spraying directly onto the well. You do want to clean the guards at the top and bottom of the unit. There's usually, typically on most units, a fan, and it usually blows bottom up. So again, sometimes you will get dust or debris underneath. Same concept there with the fins. You can use a air source and or vacuum to kind of help with that. And then with this one too, we're also going to show you how to check the temperature cutout. So again, wipe with the cloth or towel, spray it onto it. Ethanol is recommended. Most of our units have fairly robust paint and plastic, but also a lot of people use Simple Green 409, Windex, other cleaners if, again, they're not have a good source of ethanol in the shop there. All right. So again, when we say keep the well clean of any clear of foreign matter, you don't want to use any fluid to clean out the well. Again, just air, potentially in a vacuum. You never want to use any thermal grease or paste with any of our dry wells. We mill the inserts in that to such a tight tolerance that they do provide good thermal conductivity between the block and inserts without the need of this. And what actually happens with most thermal grease is it actually becomes a glue over time. So I've seen many inserts basically get glued into place while people are trying to fill these micro gaps between the wells. The oxidation on the inserts happens on both hot and cold dry wells. It's a little more prevalent with the hot ones, and as it causes the more of the brass colored inserts to kind of go dark or almost a black oxidation. For the aluminum inserts, they do just kind of go to a scaly white. But again, Scotch-Brite works really well, usually the maroon type or a 400 grit sandpaper. If by any chance you happen to drop one of the sleeves and it hits something hard or the floor, please give it a good once over before inserting it into the wells. What can happen is if you get a micro burr or kind of a ding in the insert, this can actually cause, especially in the higher temp ones, them to basically, the oxidation will bridge from that little ding in the insert, and that can actually cause them to stick. Also, if you ever get an insert that is stuck, don't ever twist the insert, because again, usually if there's one of these little burrs and you twist it, basically it kind of makes a slot and kind of locks it into place. Another piece of equipment that's really good to have on hand to kind of go down in the wells holes themselves is a typical gun cleaning kit with some pipe cleaners. That helps remove the oxidation internally with the little brass brushes. But again, as you're placing the inserts in or out of the wells, you do want to use the removal tool and avoid just dropping them into the well, because again, if you do just drop them into the well, basically the control sensors reside at the bottom of the well, and that physical shock is going to be like tapping it, which can cause the units to drift. So again, it does physically shock that sensor and cause them to drift over time. All right, so in most of our equipment, you can see here the over temp cutout. We've tried to make most of our controllers behave similarly as far as getting to different features within the unit. And this one follows the same kind of setup as the bath one that we just reviewed. So again, you're going to hit the set and exit. The unit will display the percent power. You'll hit set again. You'll see the proportional banding. And again, here with the proportional banding with dry wells, you typically never want to change this as they are optimized. However, on the baths previously, sometimes you can optimize them based on fluid type and temperature. So again, sometimes the baths will have something that is different than what was set at the factory. And then once you hit set again, you're going to see the cutout temperature. So again, internally there's the hard one that is set, and then this one is actually the soft one. So again, sometimes people will, again, in this case, not use it, or I should say use it to prevent the overtemping of a probe in a test process versus a fluid. So again, you can pull that back and run a quick check. pull it back to say a higher temper one. You can set it to 100 C and set the unit to 110. And as it ramps up, the unit should, trigger that. And again, stop the power until the unit then drops back below that. And this is the same for what we call our metrology wells. So you go to the display temperature and you'll get to the cutout in much the same way. This ones are a little different, but again, very similar in the way we've kind of designed the menus in our products across the line. All right. And now we'll move into our micro and small baths. Again, same concept here. Why are we doing this? To keep our measurements in check and to prevent downtime. So we've got here our micro bath series on the right, which is our 6102, 7102, and 7103. And then on the left, we are now showing our new tri-clamp baths, which are a little bit different. They have a full stainless steel design, a little bit different stir mechanism, and work well with a tri-clamp or clover type sensor, but they also work as a great small bath as well. And these are also our first baths to come to market with a NAVLAP accredited calibration versus traceable like our legacy products. All right, some of our tips we're going to talk about with the micro baths and small baths is cleaning the exterior of the bath. We're going to check the stir motor speed, show you the stir bar in the micro bath, and then why it's important to avoid using water in the 7102 micro bath. So again, usually want to work top down. Since these baths do use silicone oils mostly, you do want to try to avoid getting that internally. So again, if they are not in use or you've drained the fluid, I always recommend just placing a shop towel in the tank itself to kind of help absorb some of that residual fluid, and then put the transport lid on. So again, same concept here. You can use a air source or low pressure air to kind of remove dust from the vents and different parts. Give it a good cleaning that way, then do a quick wipe on the external, again spraying onto the cloth and towel, not directly to the unit. As far as the stir motor speed, some people will adjust this, again, depending upon fluid that they're using and temperature. And sometimes over time, they may need a little more stability, or sometimes I've seen them slow down the stir speed if it was cavitating. Usually not a typical problem. You can see our default settings here for the units. Most of those work across the temperature range of the unit, but if you ever do want to slow the stir speed down or change it, again, same kind of concept here. Set and exit. We're going to get to the display power, set to our proportional band, set, and this time we're going to go one more into our operation parameter and hit set, and that gets us to the stir speed setting. And then you just simply use the up or down arrow keys to take the setting. And I've seen people change these inadvertently. So sometimes if you get the stir speeds too fast, they will throw the stir bar outside of the magnetic field that is being, making the stir motor work. All right. So this is just showing again. This one is for the 6109, 7109. So instead of going into the set and exit, we just now have a setup button, which you're going to go into the instrument, which is a F2 button. There's a series of F1 through 4 on the display. You'll go instrument, then more, F4, control. You have to enter in the password, and I do apologize here. Just 1 second. Working from home, I'll just have something exciting. All right, and so once you get to that setting, You can adjust that stir speed, and most of these ones are set to 2000, which is a default. Of the stir speed itself. All right, now moving on. All right. Over time, the stir bars will lose their magnetism with time and usage. So periodically, you'll want to replace them. And again, this is sometimes to do with the stir speed we talked about. Sometimes if that common set point is causing them to get tossed outside the magnetic field, you may want to replace these. And since they are magnetic, it's quite easy to get them out. You just remove the internal basket and then reach down there with something metal that's magnetized, and it'll click onto it. You pull it out, and you can just simply set the new one down in there. And we touched on too why it is not good to use water in the 7102. This one uses a little bit different tank. It's an aluminum tank versus stainless steel. So it wasn't designed to be used with water, just the silicone oil. So if over time the tank gets exposed or becomes scratched, basically, and you use water in it, basically between the magnetic field and some of the stainless parts and the aluminum, you'll create a dialysis effect, and it'll actually eat through the tank. So again, with the 7102, that one is one you just always want to use a silicone oil with. All right. And if there's ever any questions on any of the products and you need some support on, you can always email our group at temperaturesupport@flukecal.com or call 877-355-3225. And the three guys there are Shane, Emmanuel, and Roger. Known them all for my entire time I've worked here. So they're a really good group to work with on any technical problems that you may be experiencing with the product. All right, and also you can email Christina at christina.spearman@transcat.com or call the 800-828-1470. And for that, I think I will kick it back over to Christina to see if we had any questions that have occurred in our chat box.
All right, thanks, Travis. That concludes our presentation portion of the webinar. We will now move on to the question and answer session. Just as a reminder, if you would like to ask a question, please send it through the question box in your webinar controls. So let's move on to the first one. Can isopropyl alcohol be used instead of ethanol?
Yes, it can. Again, I've seen most people use either, I've seen it used for short term, just like your off the shelf stuff you can get at Walgreens or whatever, the 70%. Usually if you're using that, it's better if you can find a 90%, again, because that's less water in it, especially if you're using it below 0.
Okay. All right, let's go on to the next one. How long do the batteries typically last in the bath controllers?
So I think in my slide we had it at 7 to 8 years, but I've seen them go as long as 10, and then again, every once in a while you might get one that's bad. I've seen them go as short as 3 to 5. So it's just kind of a battery, but again, when I was in production, we would always test them, and anything that read less than, I think it was 3.3 or 3.4 volts, we would deem not acceptable.
Okay. And the next question is there a shelf life for silicone oil?
Not officially. I don't think it goes bad sitting there, but when I've looked into this, I've heard anywhere from 6 to 18 months. But again, in my experience, I've never seen oil just sitting go bad.
All right, thanks. The next one is, we have to replace fuses in our 7341 bath often. What could be the cause of this?
That could be a couple of things. One could be a relay issue. Typically, I've seen it depending upon the age. It could be a sign of the compressors kind of going on its last leg or end of life. The other thing too with those fuses, you'll want to ensure that they are a slow blow fuse, because any of the baths, they do spike slightly upon startup with the start motor. So if you have a fast blow fuse in there, it usually will take it out pretty quick.
All right, thanks. And the next one, what are some warning signs of the silicone oil starting to polymerize?
So again, color is one, but it's not always a tell. The most recent example I can think of in my time was I had a customer call me. He said, "Hey, I left here last night. My bath was working perfectly. I came in this morning and my stability is all over the place." And I said, "Well, what temperature you're running at?" And he says, "I'm running at 156." And I said, "Well, how long has your fluid been there?" He says, "So probably several years." And I said, "Well, we need to immediately have you get off the call and drain the bath." So again, with some of the larger baths, stability of the unit is a tell sign of the bath fluid kind of starting that polymerization process.
Okay, thanks. And we have another question. It says, what fluid would you recommend for a range of -40°C to 125°C? And will I need to use different fluids for low and high temperatures?
Over that range, I think we can cover you here. Let me grab the fluid sheet. What was that range again?
-40°C to 125°C.
Yeah, so I would recommend our silicone oil. That's the 5010. It has a usable range of -40°C to 130°C.
Okay. All right. Sounds good. It looks like that was the last question. So that concludes our time for today. If you have any further questions or would like to find out more about Transcat's product and service offerings, please contact us at 800-828-1470 or on the web at transcat.com. I want to mention again that each of you will receive a copy of the slides and a recording of the webinar. Thank you for joining us today. We hope you got something out of today's presentation and that you continue to join us for future Transcat e-learning webinars. Thank you, Travis.
All right, thank you. I apologize for the dog there.
No worries. We all understand. Thanks so much, everybody. Have a great day.
All right, bye-bye.
Okay, bye-bye.